Good afternoon. This is Sandhya Sabu from the Department of Software Applications, standing here to share the concepts of software engineering. Before getting into the concepts, let us see what are the learning objectives and course outcome. Learning objective: to introduce the software development life cycles, to introduce concepts related to structure and object-oriented analysis and design, to provide an insight into UML and software testing techniques. And next is the outcome of this course. So once a student has finished learning this software engineering, the student should be able to specify software requirements, design the software using tools, to write the test cases using different testing techniques. Software engineering. Software engineering is nothing but the branch of computer science that deals with design, development, testing and maintenance. So here software engineering always mostly deals with large projects, and the main goal of software engineering is to build a software product that is of good quality, budget friendly and time efficiency. What is software engineering? Software engineering is nothing but a systematic approach that performs some core activities and focuses mainly on problem solving. It follows some engineering principles and it is a structured development process. It has a good quality and maintenance. It enhances collaboration and communication. It has a high security and good performance. So once you crack and master in a software engineering concepts, then you will be able to perform as a web developer, quality assurance engineer, web designer, software test engineer, cloud engineer, front-end developer, back-end developer, DevOps engineer and security engineer, and more jobs are also available. Here is the attributes of software engineering. So here we have 4 attributes. One is efficiency, reliability, reusability and maintainability. Efficiency provides a measure of the resource requirements of the software product. Reliability, it helps us to assure whether the product will work in the same manner in different environments. And reusability, it also helps us to assure that the module can be used in multiple applications. And maintainability helps us to provide the ability to be modified, repaired or enhanced easily. Advantages and disadvantages of software engineering. So first, here lies the advantages of software engineering. One is improved quality. So once if you are going to develop a software product, then it should be of good quality. And next one is increased productivity and better maintainability. Once if you are going to buy any product, we should have that mindset that it gives us a long period of time for use. And next one is high earnings. So by using software engineering concepts, you can produce a software product with high earnings. Next is the disadvantages of software engineering. Expensive and time consuming. Sometimes building a software project can be more expensive and time consumption can also be more longer. And next one is limits flexibility and creativity. Sometimes we cannot be able to adapt for the new features of in the present trend. And next one is deadline pressure. So we will be in a pressure to finish off that project in a particular time. Next one is complexity. Some projects will be so simpler and some projects will be more complex. So software development life cycle. If I want to develop a software product, I should follow this software development life cycle. So it is nothing but a structured process that helps us to design, develop and test good quality software. So here lies 6 phases. First one is planning, defining, designing, building, testing and deployment. So as I said, we have 6 stages of a software development life cycle. First stage is planning and requirement analysis. Second stage is defining requirements. Third stage design. Fourth stage development. Fifth stage testing. And sixth stage is deployment and maintenance. So first stage, planning and requirement analysis. In this stage, if I am going to develop a software product, first one is I should do a planning. So in this planning phases, planning, define project scope, set objectives and goals, and resource planning. So if a customer comes to me, if he is asking to develop a software product. So I should first gain what the customer needs and what he is expecting me to develop. So that is called as planning and project scope, and I should set an objective and goals that I should give the proper software product to the customer. So I should plan for the resources also. So this stage is considered as a basic building block for a software product, and this proper planning will help us to provide a quality based software. Second stage, defining requirements. So defining requirements, here the basic requirements, what are the basic requirements are needed for developing a software. So those things are done here. So in defining functional requirement, technical requirement, and requirement reviews and approve. So in this stage, the requirement is gained from the customers, market analysts and stakeholders. So based on the requirement provided by the customers, the things will be classified. Stage 3. So here is the stage 3 is designing architecture. So once planning is done, and we have done for requirements definition, and third one is designing. So once we have got whatever we are going to do, an idea of what we are going to perform. So next level is designing stage. So in designing stage, here lies two things. One is low level design and another is high level design. So in low level design, it gives us what each particular module is consist of and how does it performs. And high level design, it helps us to gain the knowledge of overall system architecture. So these multiple designs will be available in the design document specification. So based on the market analyst and stakeholders assessment, we will be choosing a particular design. Stage 4, developing product. So once the design has been predicted, the next stage is developing product. So for this developing product, we will be writing the design, we will be executing this design into the coding. That is, we will be using some programming languages to give it in a proper structure. So here the developers will be using some programming languages like C, C++, Python and Java. Next stage is product testing and integration. So we have done planning and we have done requirement analysis, and third stage is design, and fourth stage we have just we have just transformed that design into a proper code, and fifth stage is product testing. So the product testing and integration, why it is product testing and integration? Because at some cases we will not be able to do all the testing at the same time. So each module will be developed by some team, and this team will check whether the product whether the particular module executes in a proper way. So that is called as integration testing. So system testing, manual testing and automated testing. So here in testing phase, we will be finding the errors and bugs, whether the product is properly working or not. Sixth stage is deployment and maintenance. So deployment is nothing but the software product that we are building should be able to acquire all the future trends that we are going to meet in the future. So it should be currently it should have the ability to be updated as per the needs. And here we will be getting the feedback from the stakeholders and customer. Based on the feedback, we will be if any changes need to be done, we will do it. Overview of software development life cycle. So as I said, these 6 stages: requirements and gathering. So here is this planning and requirement analysis. Next stage is design, and third stage is changing the design into proper programming language development. And once the programming language coding is done, we will be testing testing the modules, and once testing is over, we will be getting into the stage called deployment and maintenance. So we have learned what is a SDLC, software development lifecycle. So to follow this methodologies, we have so many SDLC models here. One is waterfall model, RAD model, spiral model, V model, incremental model, agile model, iterative model and big bang model. First one is waterfall model. So waterfall model is considered as the basic of all SDLC models. It is considered as the fundamental model because here is this diagrammatic representation. So once one stage is over, we cannot get back to the previous stage. So that is why we call it as waterfall. Once it is fell down, we cannot get it back. So in waterfall model, each phase need to be completed and it cannot be changed in the future. So here is an example called construction and manufacturing. In the field of construction, constructing a building or manufacturing any component, we will be following this waterfall model. So waterfall model will be performed with so much of care, because once we have completed a stage, we cannot get back and we cannot do any changes to it. Agile model. Agile model is mainly concentrates to changing requests quickly. So the main goal of agile model is to give the product as soon as possible. So this agile model also considers the same 6 set of phases, but here we will have so many set of groups of people. So these groups of people performs these stages and feedback will be collected, and based on the feedback collected, we will be performing this, we will be developing the software product. So the basic example for agile model is Spotify. So we know what Spotify does. It helps us to hear lots of songs and music from Spotify as we desire, right? So those Spotify team members will be divided into groups. They will collect data as what the users desires to hear music, which music they have desired to hear. So based on that, everything will be done in the form of coding, and Spotify is done. Next thing, waterfall model versus agile model. So big comparison between a waterfall model and agile model. First one is requirement. In waterfall model, it is clearly defined because we cannot get back to the previous stage, and agile model we can change as per the requirements. Next one is client involvement. In waterfall model, client involvement is at the start and end of the product delivery. So in between, we will not be able to contact with the customer in the waterfall model. Whereas in agile model, we can get feedback from the stakeholders as well as the client. Next one is type. It is a straightforward solution, and agile model is complex project, because in waterfall model, as I said, we cannot get back to the previous stage. It is used for only simple projects, simple software development projects, and agile model is used for complex projects. Next one is time frame. It is strict and agile model is loose, because if I get the feedback from the client to change something, I have to do it. So it takes some time elapsed. So that is why time frame is loose here. And budget, waterfall model is strict and agile model is big or unlimited depending upon the changes suggested by the client. Next one is team collaboration. In waterfall model it is moderate, and in agile model it is intensive. Because why it is intensive? Because continuous feedback has been collected from the customer side as well as the stakeholders. So the changes will be occurring continuously. Next one is RAD model, Rapid Application Development Model. So RAD model combines it follows of the iterative model. So here what is the main goal of RAD model is also to give a proper software product in minimal time, because here it also is similar to agile model. It also gets a continuous feedback from the customer as well as the stakeholders. So here the example for a RAD model is Uber. So in Uber, what we will do, we will book some mode of transportation, either it is a 2-wheeler, 3-wheeler or 4-wheeler. So we will book some transportation. So how it does? So based on it, what it does, it gets feedback from the user, and it improves it improves based on the feedback collected from the user. So here in the RAD model, here what we will do, we will be for example, if I want to initialize the product, I will allot a set of team members. If I want to get feedback from the users, I will make a set of people to do that. And if I want to do some improvements, I will give a set of people to do those things. So each and everything will be considered as modules. So all these modules will be performed by different set of teams. And once it is done, we will be do the testing, and the integration testing is also done here, because all those three things together, how it works. So then only we can go for proper testing here. So for RAD model, Uber is the best example. Spiral model. So spiral model combines both waterfall model as well as iterative model. So this spiral model has all those 6 stages are classified into 4 things here. First one is objective identification, phase planning, product development, and alternate evaluation. So here all those things will be goes in a spiral way. Why it is called a spiral way? Because each and every time it goes, if for example if I have completed a stage 1 called planning, so it will again get if after going before moving to the second stage, it will get a feedback from the customer, it will get a feedback from the stakeholders. So each and every time the feedback has been collected. So all those each and for if I am going to moving through to the third stage, first stage and second stage will be evaluated again. So that's why it is called a spiral model. So here is the best example for gaming. So if I want to develop a game, so what I will do as a developer, I should know what the customer needs, what the customer expects, what they like in a gaming. For example, nowadays so many people are addicted to PUBG, right? So those games are built using spiral model. Software requirement specification, SRS format. So what is this software requirement specification? So as I said, this software developing project consists of 6 phases. All those 6 phases we have learned just now. So these 6 phases, first phase is planning and second phase is requirement analysis, right? So this requirement analysis and resource allocation should be done properly. So if this is done, if this is planned accordingly only, we can move to a next phase called development phase. So if the basement is not done properly, then the building will not be strong. So this same way SRS stands here. So the characteristics of SRS has been given here: correctness, completeness, consistency, unambiguousness, ranking for importance, right level of abstraction, modifiability, verifiability, traceability, testability, design independence, and understanding by the customer. So what are the best practices if I want to do an SRS? So first one is the language that we are going to use should be clear, and next one is avoid using technical jargon. So technical jargon is nothing but technical terms. So you avoid using unnecessarily the technical terms unless and until it is necessary. And more instead of giving it as a big paragraph, use visual diagrams. And next one is collaborate with all the stakeholders to validate the requirements, and then once each and everything should be documented. So this is the most important thing in SRS. Coupling. So coupling, what is coupling? Coupling refers to the degree of independence. So how as I said, those software if I want to build a software project, if I want to build any software product, what will I do? All work cannot be done by myself, right? So my work will be split with my team. So I will ask my team to set of team members to do planning, and I will allot some set of people to get the requirements, and I will allot some set of people to do the development phase, and some set of people will be performing this programming part, right? So all things cannot be done by myself, so it cannot be done by one person. So it will be performed with different groups. So those groups will be developing some modules. So how these modules are interdependent. So that phase is called as coupling. So here we have two things. One is high coupling and low coupling. So high coupling is nothing but how the modules are closely connected. So if one change has been done in the one stage of the software product, then it will be automatically affected to the another phase, so another module. So this is called as high coupling. Low coupling means the modules are independent. So any changes done to the one module does not have that much impact on other module. For example, if I want to get, for example, if a student is going to get an admission in a college, so he have to pass his 12th grade, right? So if he is not passing in 12th grade, so he will be in a situation not to get admitted in a college, right? So this is the passing 12th standard is one module. So getting admitted in a college is another module. So these two are both highly coupled, right?